Recording in progress.
Graph is above to show. I can't see that.
Oh, I'll expand. No problem. Thank you for your honesty. There you go. You're good. Keep going. Mm-hmm. Mm-hmm. Great. Awesome. Okay. So this is called a number line. I mean, well, obviously it's called number line. Sorry, I call it a sign chart. Sorry, that's what I meant to say. Sign chart. So yes, go some more. We can see a nurse if you need to. If it's I don't have first aid kit. I'm sorry. We do have tissues if that helps. We have tissues back there. Yeah, we have more. Or actually, you know what? Mr. Medina might have some. Go. Okay. Wow, that's very resourceful. Okay. All right. So what Lincoln just read, guys, we need to focus. All right. What Lincoln just read, anything that's shaded means that the graph is above the x-axis. Okay, if the graph is above the x-axis, are the y values positive or negative? If the graph is above the x-axis. So if I had a graph that looked like this, right? They're positive, right? So clearly these portions have positive y coordinates, right? So when you see the shaded portion on the sign chart, the graph's above the x-axis, or the y coordinates are positive. Okay, so that's what that indicates. So between -3 and -1, the graph is above the x-axis. To the right of 4, the graph's above the x-axis. So how are you going to graph it? I'm going to do a kind of an overlay the best way I could. I'm going to do this. I'm going to put 4 here, -1, and -3. And I'm going to make a graph that looks like this. It's going to take a little while to get the hang of it, but once you get the hang of it, it's not that hard. And it's actually the best way to do graphs. In pre-calculus, you do sign charts almost daily. So this is actually a great way to get you ready for pre-calculus for next year. Graph is above the x-axis in these portions here. The graph is above the x-axis.
In the shaded?
In the shaded portions. Or the y coordinates are positive. Okay, so take a look at my graph. Okay, please. Between -3 and -1, see that little portion is above the x-axis. The right 4, the graph's above the x-axis. All these y coordinates are positive. All these y coordinates are positive. When you're below, clearly the y coordinates are negative. So that's how we can translate the sign chart to a graph. And we're going to obviously go the other way around and make sure we do a sign chart from a graph as well. But we use sign charts as another way to help us make these graphs accurate. How do I write an equation or possible equation from this? Because you're asked to write a possible equation. What are my x-intercepts here?
3, 1.
So give me the factors. X
Minus.
not x minus.
3.
Keep going.
X plus 1, x minus 4.
Perfect. There you go. And by the way, I could have a coefficient in front, but I chose not to. How come those are squared? How come these are all just
crosses?
Just because no bouncing at all. Just zero bouncing, right? By the way,
How would you know if there was a bounce?
great question. We're gonna get there in a moment. That's a great question. Probably the best question I've heard in a while. It's a great question.
Specifically, or like in general?
In general, that's a great question.
Like best question this year question?
Yeah, because that's
Wow.
because this is why we have sign charts. Yeah. Okay. So let's talk about part B. This is exactly what John was talking about. here we go. So this right here. Okay, this is why we have bounces. This is why we have bounces.
No one put this part, because that's where my nails.
How many x-intercepts do I have here, guys?
3.
3. My shaded regions is clear between these two and these two. So we have 2 intervals that are back to back being shaded. Where's the bounce going to happen? Yes, exactly.
Come on.
I'll show you why. You'll see why. And this will be the aha drum roll moment, if you want to call it that. -5, 0, and 2. Okay, so clearly the graph, according to part B, the graph is above the x-axis from -5 to 0 and from 0 to 2. Kind of sounds redundant because 0's already included, right? So it's negative to the left of -5, right? Right now that's negative. Okay, it's got to hit 0 clearly. Are we going to cross?
No.
Because if you cross, what happens? We don't want that. That's no good. So we have to bounce. We have to hit 2, and we're negative. That's why bounces happen. Back to back.
Wait, but how do you know it's back down, not just straight up?
Because it's negative after 2. It's not shaded.
No.
It's not shaded. It's only shaded from -5 to 2. It's bold from -5 to 2. It's not bold afterwards. So sometimes we do this, guys. We put little plus signs here.
Okay.
So we're going to see an equation in a moment where we'll apply the sign chart to it. But a possible equation could be this: y equals x plus 5. Okay. If 0 is an x-intercept, what do you say the factor is? X, but x squared because there's a bounce, and then x minus 2. So you write like this.
To draw the sign chart? What
Was that?
we have to draw the sign chart?
Yes, I'll ask you guys to draw a sign. I'll ask you guys to do that. Correct. I just said rearrange it because it's good to have x squared to the left of everything, but yeah. Okay, let's try this a couple more times and then we'll move on to the next page. And then we're going to create number lines for the graphs for the equations below. All right, here we go. Part C. Plus, minus, minus, plus, minus, plus, minus, plus, minus. So I'm adding a little more to this. Okay, now you guys got a hang of it. Anything that's bold is positive for y. Anything that's not bold is negative for y. When y is positive, you're above the x-axis. Y is negative, you're below, as we naturally expect from the coordinate plane, right? So clearly my graph has to be above.
So then does it bounce in the negative at 1?
Yes, there's another bounce here.
Easy. A W.
Just like the Warriors, they got the W. All right. Okay, so here's what's gonna happen. It's gonna be positive before you get to -1. It's gonna cross because it's gotta be negative afterwards. It's gonna curl back and hit 1, but it's gotta stay negative between 1 and 4, so it deflects off 1, and it comes back up like this. And what's really happening is that at 1, it's gonna be a square factor. So the possible equation would be y equals x plus 1, because there's a cross, x minus 1 to the second power, and finally x minus 4. Does that make sense? What we're seeing here? Let's try this one more time. Now here you have an alternation of signs. Negative, positive, negative, positive, negative. So it's gonna be a bunch of crossings. So I draw the coordinate plane. Notice when I draw the coordinate plane, I'm being very deliberate. I'm putting the y-axis where I feel 0 is on a number line. So it's a nice overlay between the number line and the coordinate plane. This is truly how you should do polynomial graphs. I'm not sure why we didn't do it in the last units, because that's how I really wanted to teach it to you guys, but it's okay. So So you're negative before you get to -2. Pause between -2 and -1. Negative between -1 and 1. Positive between 1 and 2. Negative when you go 2 to the right. Looks like that. By the way, how many x-intercepts do I have?
4.
How many peaks and valleys?
2.
3. There's always one less. Right. Okay. So now let's actually generate this for number 2. All right.
Sign chart or?
Yes, sign chart. It's number line sign chart, same thing. Okay, part A. Here's how I do it. What are my x-intercepts?
2 and -5.
So you're gonna locate those
Balance it.
on the number line.
5.
Okay. Now, those are my x-intercepts. Now, what I'm going to do is this. Pick a number greater than 2.
3.
3. Is 3 minus 2 positive?
Yeah.
Is 3 plus 5 positive?
No. Oh, yeah.
When you multiply a bunch of positive, what do you get? Positive, good. So I expect positive in this interval. So what you're doing is you're doing partitions. The partitions are defined by the x-intercepts, as they should be. Because y is 0 at the x-intercepts, right? You're not positive or negative. You're not in between that limbo phase, right? It's at 0. And it's deciding, should I cross or not cross, right? Well, let's find out. -5 and 2. Give me a number between -5 and 2.
1.
1, great. What's 1 minus 2?
-1.
Negative. It's negative now, right? What's 1 plus 5? So 6 squared is positive, so if I multiply by -1, negative. Good. Okay, so it's negative. Great.
That's -4. It bounces.
Okay, last interval, yes. Give me a number less than -5.
-6.
Great. -6 minus 2, negative positive. Negative 8. -6 plus 5 is. But you're squaring it, so positive times a negative. That's why we have a balance of squares. That's why. I know I'm getting very excited, but that's why you have that. Because now we get away from memorizing. We now understand. We now connect algebraic to graphical. Yes, John, go ahead.
Why do we have to do this if we can just graph it? Because we can, I'm able to graph that.
Okay,
first.
great question. When we get to more advanced graphing, this will be very helpful. When we get to rational functions, we're going to get to graphs that look like this. They're going to be like x squared plus 5x plus 6 over like 2x squared minus 8. When we get to that kind of stuff, the sign chart will be tremendously helpful. Next week.
Oh.
Yeah, I know you have APs.
Yeah, me too.
Was that? Or maybe later this week, actually. Maybe Friday, I think.
Is that going to be on the test?
Oh, yeah.
Oof.
And the final.
And
And the final. But remember I talked about at the beginning of the year, that's our key, our key thing that we do. I'm sorry, lots of words. It's the end of the year. But the key idea is that we want to connect algebraic to the graphical. That's what we're trying to do. And numerically as well, like numerically understand what's happening. So there's going to be a balance at -5. Do we expect that? Okay. Once again, now let me show you a way to do P4. So that was that's P1. That's P1. I don't know why I call it part A. P1. Okay. Let's do P4. Okay. I'm going to show you an even more efficient way for doing this. And this is how we actually, in AP calculus, how we expect our students to, or even at level calculus, we expect them to do it this way, just to save time. What are the x-intercepts here for P4?
5.
Perfect. Okay, let's put it down. So -3, -1. So these are my partitions. Okay. Now here's how we can go about this in a very efficient manner. Excuse me. Okay. We'll start with the rightmost interval. Give me a number larger than 5. 6. Positive. 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 They're all positive. Right? So it's going to be positive over here.
What do you mean they're all positive?
When I plug in 6 into this, 6 plus 3 is positive,
Oh.
6 plus 1 is positive, 6 minus 1 is positive, 6 minus 5 is positive.
Okay.
So
So that's why I meant all the
is it
time.
very far that negative?
Okay, now, you could start testing all the values between 1 and 5, -1 and 1, -3 and 1, and let's say -3. Or what if they have something between 1 and 2? You gotta test 1.5? That's crazy, right? Sometimes they get nuts. Here's what we're gonna do now. Take a look at 1. Sorry, take a look at 5.
Negative, because it's full cross.
Hold on. Do you see a square symbol next to x minus 5?
So it's negative.
No. So there should be a sign change. Because if I plug a number smaller than 5, this now becomes negative.
Yeah, that's positive.
Okay, at 1 comes from x minus 1. Do you see exponent here?
Positive.
So switch the sign again.
And then negative.
Okay, -1. We don't see an exponent either. You assume another sign change. You don't have to test it out anymore. Once you know the rightmost interval, and you know whether these are squared, the only place you're going to see the same sign is when that's an even exponent. The only even exponents for x plus 3, that's going to stay the same because of the bounce. Bounce, C, C, C. Yeah.
-1 or like half a plus.
That's -1.
No.
That is a plus sign.
Okay.
I'm sorry about that. So once you get the hang of it, you don't really need to test every single interval. Just test the rightmost interval and then look at the factor that it comes from. If the factor has an even exponent, keep the sign the same. If it's an odd exponent or don't see an exponent, you assume it's 1, make the sign change. Always gonna be sign changes when the x-intercept comes from a factor with an odd exponent.
What about like if we have an A value?
Well, that will impact the rightmost interval, as we see for P5, but then everything else will take care of itself afterwards. Actually, since you brought it up, let's look at P5. P5, here we go. Okay, I'll do my number line. Where are my x-intercepts? 0 and -4. Remember, x counts, right? So those are my x-intercepts, right? They're, excuse me, 0 and -4. Okay, let's try the rightmost interval. If I plug in 1, what's -0.1 times 1 times 1 plus 4 cubed? What's 1 plus 4? 5 cubed. What's that times -0.1 times 1? Negative or positive?
Negative.
Negative. That's negative.
So that's positive. And then negative.
Okay. So again, why am I starting with negative? Plug in 1. What's -0.1 times 1? -0.1. And if you do -0.1 times 5 cubed, that's still negative, right? Does that make sense why it's negative? We're okay with that?
Yeah.
Okay.
Positive.
Now, the 0 comes from this. That has an odd exponent, so you assume a sign change. And the -4 comes from x plus 4 cubed. That's still an odd exponent. We have another sign change.
So the exponent's odd, the sign changes?
Yes, exactly. Because if you were to plug in a number slightly less than -4, all of a sudden, this becomes a negative value. And that's why we see the sign change, and hence why we cross the x-axis. Right. Okay, and lastly for P6.
P6, there's no P6. P2.
Oh, P2. I'm tripping. P2. Here we go. -2, 2, and 3. Now, the 2 is a factor, of course, but it's just 2, right? You don't worry about it. Okay, Charlotte, Nathan, guys. Plug a number larger than 3, like 4. If I multiply all that out, 2 times 2 times 6 times 1, all that is what? All those positives multiply to what? A positive, great. Are all these factors have any even exponents? So you know what? Don't waste your time. Just do that.
Is that what you want on like a test?
Yeah. I want you to save time.
And the two doesn't matter?
Because here's the thing, if I plug in 2.5, right? I mean, sure, go ahead, go up plug in 2.5, that's positive. 2.5 minus 2.5, 2.5 plus is 4.5. Ooh. 2.5 minus 3. Uh-oh. Sorry, I got more kids. So sorry. I'm losing my voice. Sorry. I gotta slap that. Uh-oh. Yeah. Sorry, 2.5 minus 3 is -0.5. Bottom line is signs change. All right. And I got that recorded too. It's hilarious. All right. All right. Now I don't know if I want to do this problem.
Do it. Do it.
Okay, we'll do it. We'll do it.
I'll do it.
Okay, we're not gonna do page 4. It's a little too much. We don't have time, but I've only got a few more minutes left, guys. Actually,
Do it.
let's hold off on let's do page 3 again. Let's go to page 13. No, that's the long division. I'm gonna say that for another day. Okay, let's do this problem right here. This is what I want to do. Okay. This is the last problem we'll work on today, guys. Okay, guys, quiet. I want to finish off strong here. Okay, so can x minus 5 be a factor of this? Okay, so let's think about it. If I multiply, Alexander, yeah, thanks. All right. So if I multiply x minus 5 with a bunch of other factors, there's no way it's going to multiply to 6 because 5 is not a factor of 6.
Or 3.
So could this be included? The answer is no, because 5 is not a factor of 6. That number there is not a factor of this. So what we'll do for now, let's go to Desmos. Plus is crazy, it's x4. It's kind of nuts, right? So let's go to Desmos. Here's a little slow here. Got too much going on right now. Okay, so let's type in the equation. Once it's Desmos wants to wake up. Y equals x4 minus x cubed minus 5x squared plus 3x plus 6. No, I got it. Okay. Okay, look at the graph. That's a weird number. Nathan, come on, dude. Stay focused. Okay. Good. All right. Okay. I have 2 wacky numbers, and 2 numbers look pretty clean. 3.91 and 2 are my clean numbers, right?
Why are they the exact same though?
They're conjugates, actually. That's why. We're going to talk about it in a moment. So what this means is that I could divide by x plus 1. I could divide by x minus 2. Now, if I ask for exact answers, if I say I don't want decimal answers, I want a radical answer, then you can't report 1.73 because that's an approximation. So how can you get the exact answer? You have to do polynomial division. Here's how it looks. So definitely have x equals -1, and definitely have x equals 2. So your factors are x plus 1 and x minus 2. Okay. So now you've shown a list of possibilities. What factors in short list really are factors of p of x? Of course, x plus 1 and x minus 2. And by the way, are -1 and 2 factors of 6?
Yes.
They are. So this will be okay. By the way, 1.73 is root 3. You multiply root 3 by itself, you get 3. -1, 2, and 3. If you work all out, you should wind up getting 6. So here's what you can do. Okay, in the interest of time, I'm just going to jump to parts E and F. This is now divided. Great. Let's do the division. 4 columns when you have 4 power. Negative, we had x plus 1 is a factor, right? Because because -1 is an x-intercept, right? Okay. What multiplies x4, guys? x3. And then we're just going to kind of go somewhat rapid fire. What do you add to x3 to get the -x cubed? -2x cubed. So you get -2x squared. So the multiply 1 to get -2x squared. Okay, what do you do to get the -5x squared? Hopefully you see that, right? You get -3x, -3x. That'll be 6x, 6, and 6. So you wind up getting all this junk if you do division correctly. Now, in the interest of time, I could do the division again, but hopefully you guys can see that there's a factor by grouping. We had this on the last test. Oh, that's squared, by the way, sorry. You factor out x squared, you get x minus 2. Oh, look at that. I should get x minus 2, right? And guess what? I have an x squared minus 3. What are my x-intercepts, guys? Plus or minus root 3 or 2. So that's how the polynomial division can be done. You can actually graph these pretty accurately. Without a calculator, find the x-intercepts, and then go ahead and make your balancing. So, oh, to be continued. Good luck in your next class. See you guys later. Welcome. And if you borrowed a calculator, can I please see Lois and John? Thanks. Okay, have a good day, guys.